Aloha, Richard Halverson here, and today in this video we're going to do the min-heap assignment. And in this assignment, we're going to write a Python program to do a heap sort, but we're going to use a min-heap instead of a max-heap. And so the book shows us how to do this using a max-heap, and here we're supposed to the a heap, just to refresh your memory, a heap uh, is a binary tree where each node is greater than or equal to any of its children. Okay, and so that's a max heap, and a min heap would be each node is less than or equal to each of its children. And so we're supposed to revise the heap sort program to use the min heap instead of the max heap. So it's supposed to run like this, where you enter some numbers in, and it prints them out in sorted order. Okay, so um, let's look at our textbook, and this is a chapter 7 thing, and let's go first. Let's look at this section on heap sort to see what a heap is. Uh, we will review that, and then let's go to the heap class and the sorting using the heap class, those two sections, and there is the code for doing a heap sort using a max heap. And we'll just take that, copy that into, copy those files, and then modify it so it does a min heap instead of a max heap. All right, so if we look at this heap sort, the way a heap sort works is it starts out by uh, taking a list of numbers and representing them uh, um, using the list representation of a binary tree. Uh, and then it uh, creates a heap out of that list. And then once it has created the heap, then it is able to pop off the top node and then reheap it and keep on popping off the top node, because the top node is going to be the largest uh, node, because of the definition of a heap. Each uh, each parent node is greater than or equal to either of its children. Each node is greater than or equal to each of its to either of its children. So here's an example of a heap. We've got this is a heap because 42 because let's start with the uh, the leftmost or the rightmost binary tree down here. 39 is greater than or equal to either of its children. 32 is greater than or equal to either of its children, and 42 is greater than or equal to either of its children. So this is a heap. And so the way you, let's see, does this 42, I'm not sure what this is actually showing, but let's there, there's a nice heap sort visualization here that we can look at. Let's see, can I make this a little bigger? Okay, so let's randomize this array, and we see it's a random array here, and 0 to 30 elements. It means there's 31 elements, and let's see this heap sort animation. Okay, so the first thing it's going to do, let's just click on heap sort. Here is the, let's see. Okay, so this this is the um, this down here is a binary tree, and this is the list representation of that binary tree. So we're going to start out by taking this list of numbers here and assuming uh, a binary tree list representation of a binary tree. So that's what this binary tree um, turns out to be. 592 is the first one, and 731 is the second one. This is the third one. This is the fourth one, the fifth one, the sixth one, the seventh one. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. 744 is the last one. See? So then the first thing that this heap sort does is it makes sure that this whole thing is a heap. Well, it's not a heap. 731 is bigger than 592. There's all kinds of things here that make this not a heap. So what it does is it starts in the lower right-hand corner here with this 552. It compares the two children, and it may have to exchange. Like in this first case here, it sees that the 744 is larger than the 552, so it's going to exchange those two. And then it goes on to this one, and 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 then it goes to here, 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 and then when that's all done, it'll have to be a heap. Okay, so let's watch the animation until we've fully heaped this thing. So I'm just going to speed this up maybe a little bit and play it. See these two compare, and this one, so these exchange. This one, the 280, 230, this exchanges, this exchanges. This is fine. This is fine. This is exchanging. This is exchanging. This is fine. This is exchanging. And then it's got to look down here because it might have to reheap again down here. Sure enough, it does. Then it looks at these two. Looks at these two. Reheaps. Looks at those two. And then it looks at those two. And then has to reheap down. It looks at those two. Then it looks at these two. And now we're done. Okay, so hold on. Okay, so you see, let me just go back one. All right, so this now it's fully heaped. Okay, each node is larger than or equal to either of its children. So now that we're done heaping, the way the heap sort works is it starts by pulling off the top node, and that's going to be the biggest. And so the way it does that is it exchanges it with the very bottom node here. So it's gonna take this 978 and exchange it with the 105. So the 105 is going to go up here, and the 978 is going to go down here, but then it's going to be dropped off. So this heap is going to end up being one node smaller. So the way it's going to build it, the sorted list, is it's going to first put the largest one in the top slot, then the second largest one in slot 29, and the third largest one in slot 28. And you'll see it being built. Each time it pulls the top one off by exchanging it with the very bottom one, and then it reheaps. And then it pulls the top one off, exchanges it with the bottom one, and it reheaps. And each time it reheaps, it only takes log to the base 2 steps at most to reheap, because it just has to traverse down the binary tree, at most exchanging as many levels. Okay, so now this is done. Now this is all heaped. Let's watch it animate, and now you see the 978 is up here, and then next the 894 is going to go right here. Exchange. See, there it exchanges, and now 894 is here, and we keep on going. Speed this up, and we see that each time we pull off the top one and stick it, we pull off the top one by exchanging it with the very bottom one, and then we see the very bottom one disappears. It gets added over here and removed from the heap. And so this is going to keep on going until all the top nodes are pulled off. All the top nodes are exchanged with the bottom node and pulled off, and then it keeps on going, and then finally it's done. All right, so this is a max heap, because the biggest one, the way the heap was designed is the biggest one is always at the top. We're supposed to take a max-heap program and convert it to a min-heap program. So let's go back to our table of contents and find the min-heap code, or the max-heap code, and that's going to be this heap class, and then this little program here, which uses the heap class. So I'll tell you what I'm going to do is I'm going to load up Visual Studio. I've opened up my Visual Studio. I'm going to create a new project, and I'm going to call it, it's a Python console project. I'm going to just click next here, and I'm going to call it min-heap sort. How's that? Min-heap sort. Create. All right, here we are. So first of all, let's copy over this code. Let me go back to this textbook here, and let me go to heap. Let me go to this. Okay, this is the sorting using the heap class. And this uses this heap class. So let's see what the code is here. So this is going to be my main code. I'm just going to copy this, copy, and I'm going to paste it right here. Why not? Paste. Okay, and then that heap class. Let me put that in there. This is let's go back one page. And I'm going to add, let's see, I'll just do a right click, add new item, new item, empty Python file. I'm going to call it heap.py. How's that? Heap.p. I should call it. Should, it's, well, it matters. Don't think it matters. So, and in there, I'm going to go back to here, and here we are. We thought we went too far. Here we go, the heap class. Okay, so this is the heap class, and it's a regular class. You remember classes? Let me click on answer here, and we see that there are a bunch of methods here that this comes along with. You're able to add something to the heap. You're able to remove something from the heap. You're able to get the size of the heap. That's how many nodes or how many nodes it has in it, how many elements in the list, whether or not it's empty. And you're able to peek at the top of the top of the heap to see what the top object is without popping it off. This thing remove pops it off. This just looks at it. Yes, and then get list. This returns an entire list if you want to just get back, get the heap back out again and list it out, and we're going to in fact use that. Okay, so here's this heap.py, so I'm just going to copy this. Hope this works. Copy this out, copy, and I'm going to go back over here, and I'm going to paste it right in here in this heap.py, paste. All right, very good. Let's go to this back to here, and I'm just going to run this thing, see what it does. Start. And this pops up, and boom. Oh, look at that. It's sorted that whole thing. That's nice. It is sorted. Okay, so that's fantastic. So now we have to make it so it asks for some numbers, and then it sorts them. So let's do that. Instead of this list thing here, I'm just gonna comment that out. And instead, I'm going to put, let's see, I'm going to put something like about, gee, that's too bad. These, let me see if I can. So I'm going to do this, this. All right. So I'm going to do LST1 equals uh, input, enter some numbers to be sorted. And I'm gonna get that. And then I'm gonna do, let's see. No, I'm just gonna have this be string. This is gonna be nums. And then I'm gonna say LST1 equals list of nums dot nums dot, wait a minute, what am I doing here? Dot, this is right. Nums dot split on a space. So this is going to take nums. It's going to split it into an array. And this is going to turn it into a list. And I'm naming it list1. So then I can convert, because I want it to be in this form, because I want that final thing to be LST, because all the way through here I use LST. So I'm going to get to LST. It's going to be LST equals, and so I got to convert these strings. These numbers are going to be strings, and I got to convert them into floating point numbers. So for each float n for n in LST1. Okay, so for each number in LST1, it's going to be a string actually. It's going to be a string type number converted into a floating point number. And that's going to be this array thing, this list array thing. And that's going to be stored in there. No, it's going to be stored in there. All right. So that takes care of that. And then this is going to be, this calls the heap sort, which is calls this thing. And then this is going to loop for every V in here. It's going to, okay, so it's going to sort it. And then after that, it's going to list out the final sorted values. Okay, so let's try this. I'm going to copy this. Oh no, this has got to be spaced. It's got to be separated by spaces. All right. So let's run this and see what happens. Start. Oh, we got an error here. List is not defined. I've got something wrong here. I got my indents wrong. Oh my gosh. This is supposed to be here. Right. Sorry. Yeah, this is this method. This method declares a heap, loads up every element in list into the heap, and then it starts pulling off. It removes the top node off of the heap, one node at a time, and shoves it back into list from the bottom or from the back end. This is the uh, when I is 0, this is the last element position. When this is 1, this is the second to the last position, and so on. So this pulls the top node off. It pulls it off and then it reheaps. So this method here returns the top node, the value of the top node, and then it reheaps it. And what this does is this adds to the heap, and then when it's done, it's a heap. It's a heap again. So anyway, so I've indented them properly. Let me try this again. There we go. And let's paste in these same numbers as those, and I press enter. And sure enough, it is sorted. Comes out sorted. I gotta fix this print. All right, so let's see. All right, so what I'd like to do is to make some modifications to this code so I can see what the heap looks like after it has been created. So here is where we call the heap sort. This here is the class, and this is the add method. This is the remove method, and we can see that whenever you add a node in, it does this thing, it reheaps it. And when you remove an element, it exchanges um, it exchanges it here, it pops off the top one, whatever, and then it reheaps it. And this returns the size, this returns if it's empty or not, this takes a peek at the top element, and this returns the list. Okay, so if we go back here, um, so here we get the list, comes in here, we read it in, comes in here, comes in here. This declares a heap from the heap class, declares one of these dudes. It's got all these methods now that can work. And then here we loop one list element at a time, and we add them to the heap. Okay, so right here, and then okay, right here, there's a heap right here. I like to display out that heap. And then once it's all done, once you've added everything to the heap, here we remove one node at a time and stuff it into the tail end of this list again. So right here is where I want to display out the heap. So what I'm going to do is I'm going to declare a list2. Let's see, I'm going to declare a list LSTS st2 is equal to heap dot get list. That works. And then now I'm going to print this thing out, and I'm going to print it out looking just like this. Print it out looking like this. Copy, put that right here. LS2. Okay. So this is the heap. So okay, so it's going to print out. We're going to enter in the list. Then it's going to print out the heap, and then it's going to do the sorting, and then down here it's going to print out the sorted list. Okay, let's see what it does. And let's paste these numbers back in again. Okay, so this here is the heap. Well, let's see what that looks like. I'm going to pull up this whiteboard thingy here, and I'm going to try to draw this heap. Oops, I don't need to do that. Let's see now. I've never done this before. It's new to me. Okay, so we have 53 is first. So I'm going to draw 53. Oh. 53 with a circle around it. And then it's got a 3, 3, and then it's got a 5, 5, and then it's got a 1, 1, and then it's got a 3, 3, and then it's got a 4, and then it's got a -4, -4, and then it's got a -44, -44, and it's got a 0, and then it's got a -3, it's got a 2, it's got a -5, -5, it's got a 1, a 1. Okay, so that is definitely a heap. 53 is bigger than 3 and 5. 3 is bigger than or equal to 1 and 3. 5 is bigger than or equal to 4 and -4. 1 is bigger than or equal to -44 and 0. 3 is bigger than or equal to -3 and -2. 4 is bigger than or equal to -5 and 1. So it's definitely a heap. It's a max heap. Nice. Okay, cool. Done with that. And so we see, and then by pulling, is that thing still here? Did I get rid of it? Oh well. By first pulling the 53 off, shoving it in there, reheaping, then you pull the 5 off and shove it in there, pull the 4 off and shove it in there, and so on. All right, so now let's see how we would change this to a min heap. Okay, so let's go into here, and let's find all the places where we are comparing two nodes, and we compare two nodes and then we exchange. And what we want to do is instead of exchanging if if a particular node is bigger than the other, we're going to change it so if the particular node is smaller than the other. Okay, so it's comparing two nodes. It's comparing the value of two nodes. Okay, so here's adding. So here's the reheaping. So we added, when we added, we probably added to the very end. Yeah, we appended to the end, and then we reheap. Okay, so we start out with the current index being the node that we just added, and then we figure out what the parent of that node is. This is the formula for figuring out the parent, and then here we're doing a comparison. If the current node is greater than the parent, so if a node is greater than its parent, then we want to exchange them. Well, that's what we would do for a max heap. But what we're going to do is we're going to change, modify for min heap. And what we're going to modify is we're going to make this, instead of a greater than, we're going to make it a less than. So uh, uh, change greater than to less than. That's what I just did. Okay, so that's one place where we exchange. Let's go down. Okay, now let's go to remove. Okay. If the current index, okay, this is just test to see if it is, this is comparing indexes, not values. Okay, here's one. Here we're comparing a list value, which is going to be probably the left child. This compares the left child value with the right child value. And so if the left child value is less than the right child value, then we set something. Well, I'm just going to change that. So I'm going to say change this to change less than to greater than, or min-heap. So I'm going to, it was less than, I'm going to change it to greater than. So this is for the actual comparison. Here you're doing this thing where you're comparing the two children nodes, and you're finding out what the bigger of the children node is, and then you're going to compare whichever that one is with the parent. And so we want to change everything to a smaller. Okay, so this finds the this max index is greater than the, if the left one is greater than the right one, then we want to deal with the left one. Okay. All right, and then for this one, we would reverse change less than to greater than for min-heap. Yeah, okay, so this gets changed to this gets changed to greater than. If current index is greater than the one below it, yes, then we exchange. Okay, so if the one above it is greater than the one below it, then we exchange. Okay. All right, so that's we did that. Okay, so if this works, it should we should see the things sort in the opposite order. Let me see what this ends up being. And let's enter the numbers here. And we end up, look, it's sorted in reverse order. And this should be a min heap. So let's see if it's a min heap. Does this thing still work? Oh, look. Oops. Let's see. All right, so let me, that's the other one. Let me get out of the way here. Go here, go here. Can I get rid of this thing? Yeah, okay. Okay, let me, now can I do this? Okay. So I'm gonna confirm that this is a min heap. So I'm gonna do minus 44. Use this thing. Minus 44. And then down here is minus 5 and minus 4. And down here is 0, 2, 1, minus 3. And then this is going to be 3, 3, 1, 3, 4, 5, 53. Okay, so this goes to there, 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 there. Okay, so 44 minus 44 is definitely smaller than minus 5 and minus 4. Minus 0 is definitely minus 5 is definitely less than 0 or 2. 0 is definitely less than 3 or 1. 2 is less than 3 or 4. 1 is less than 5 or 53. Minus 4 is less than 1 or minus 3. Okay, yes, so this is definitely a min heap. And so what we do is we start by exchanging this 53 with the 44, exchange these two. And so the 44 is down here, and that's sort of removed, and this becomes 53. And then we got to reheap this, we got to re-min heap this, and this gets pushed down to tier probably, and so on. So let's all right, so we are close. It's not sorting. It's instead of it's sorting in the wrong order. So it's sorting in decreasing order instead of increasing order. So how do we fix that? Well, let's see where we build this array. This array is built right. Okay, here we when we pop elements off the list, we push them into the uh, or when we pop elements off the heap, we push them into the list from the rear end. Well, instead, let's push them in from the front. So let's do this. I'm going to copy paste this. Now I'm just going to say list. let's see. Yeah. Oh yeah, right. Okay. All right. So yes, I just pop them in from the front. Starts out at 0. Just do that instead. Let me comment this out. All right. So this is going to populate from the starting at the beginning. See if that works. All right. Yes, it does. So it does it in increasing order. Okay. So that looks good. So you can clean this up. Is it done? Yes, it's done. And so you would save this all. Save as, save all, close solution, exit. And let's see, where is it? Here. So here's the, you open this up, here's the main program, this is the class, this is the solution file, this is what you double click on and start back up again. And so you can simply send this to compressed, and we end up with this, and we can then simply do browse, go to my desktop, find my, this one, min-heap sort.zip, and submit. And there we go. So let's see, how did we, let me, this was number 3. And you want to make sure that it displays out like this. Okay, well, very good. Hope that helped. Thanks for watching.